first problem is count derangements, ninja and the French, 0-1 knapsack, combinations of 100 men's mum squares. The logic behind the first one was very interesting. Since we are finding the derangements, let's say for this 0, 1, 2, 3, so we can't place 0 at a 0th index. So we can place it at either 1 or 2 or 3. So let's say we are placing it at some ith index. Let's say I will be 2f, for example. So there are two possibilities. Either we completely swap them. So that would be like a derangement. 2 is not at its original position and 1 is also not original position. So it is like let's say we're defining solve and solve of n minus 2, because we have placed 0 and 2 correctly. We have just swapped them. So this aligns with the derangement part. And this is one condition. And suppose we don't completely swap, we place 0 at the 2, but we don't want 2 at 0 position. So think of it like this. Okay, you don't want 2 at 0 position, you don't want 1 at 1th position, you don't want 3 at this position. So this becomes the same derangement problem solved and minus 1. Because only that time only 0 it adds 0 aligns with the derangement problem our solution, but rest others are not placed at the correct positions. So this part is like this. Here's n minus 1 because for 0 we can place at n minus 1 their choices. N minus 1 is multiplied with sum, and sum is these two, n minus 1 and minus 2 dp. Okay, so logic behind is better interesting. Okay, this part is completely same. Okay, the ninja and the French. Okay, here also like this. Here you have to think like if you go for, let's say, there are n fences, and here consider like a two part. Yeah, our last two fences have same color and only one, and they have different color. If they have the same color, it will become condition like this. If they are different color, it will be like this. Okay, if they have a different color, how is k minus 1? Because let's say last two and the third, let's say third is the color red, so we can't keep a red here because there will be mismatch. So that if you think of the logic, then there you will find that these two will come. The same here comes, because if we keep k minus 1, if you go for k, then it will become case of last two same, but we are keeping it at two different, and this is last two same. Just think of the logic, you will find this. This part is not difficult, just figuring out this part was the main idea behind it. Same goes for this. Okay, so just 0-1 knapsack problem. Okay, this was the first time I was introduced with TP 2D DP, but okay, especially here you include the concept of include and exclude, and also this was a bit interesting. Just keep it as, just see simple recursion one. We are starting from index n minus 1 and we are going from right to left, let's say, and if we reach for the base case index 0 to 0, and if it's still there is capacity in the bag like knapsack, and check like if capacity is greater than our weight 0, then just add value 0, and if it is not, just keep it as 0, and then keep on adding, and we're getting the max of include and exclude. Okay, next some combination sum. This felt a bit similar to the recursion problem we solved, like possible paths. We just simply going for all the recursions possible, and if target as d0, return 1 because this is a possible solution. If we got less than 0, return 0. This is target total sum. We are keep on adding in the answer, returning the answer. part was get min square. So let's say there's a number 6. You want it to be sum of 4 plus 1 plus 1. You want it minimum. Here answer is 3. 1, 2, 3. You want to keep it minimum. So basically I first created a different kind of vector. Let's say the n is 20. So I get a vector like vector of square. So 1, 4, 9, 16. And use the same concept of minimum elements, like let's say min coin problem, same kind of thing. So for getting 20 we can go for 16 then 4. So the minimum problem we solved yesterday, it was similar to that. With this we just cause the created this vector, this kind of vector, squares of each number. Okay, and this 0 and max, and we traversed, got min. Okay, so that's it for today.